Hello everybody, now we are going to talk about application of thermodynamic in air source heat pump. For the name, air source heat pump is a device that takes heat from the outside and pump it to our house for heating purpose. It also could take heat from the house and then pump it out the house for cooling purpose. But in this video, I will explain the heating concept only. There are many varieties of air source heat pump out there. For example, like this heat pump looks like an air conditioner. It's what we call as a mini splitter heat pump, where it's work for heating and cooling purpose. Next, here is the diagram of heat pump. There are two main units, which is the outdoor unit and indoor unit. Also, here is a insulated pipe connected them together. Here are the detailed diagram of the heat pump. It shows what is inside it and how it works of the diagram. So, for the heating purpose, refrigerant is a substances that were used in the system because of its ability to condense and evaporate at a certain temperature. So first of all, this refrigerant was located at the compressor, where it will be compressed. It will be compressed. So because of this compression, it will be high temperature and high pressure, which is indicate in this in this red line. So this red line is a saturated vapor state. So after this refrigerant goes into the reversing valve, so it will be decided. So this reversing valve will be decided which flow the refrigerant will go. So hence it will go into the heat exchanger coil. So this indoor heat exchanger coil will condense this refrigerant. So the magic behind this effect is because of the surrounding air inside the indoor is much colder, so the heat move from hot to cold, so it cause the surrounding is heating. So this is what we call as a second law of thermodynamics. Second law of thermodynamics that heat move from hot, always move from hot to cold. And then there also a fan inside this heat exchanger coil. This fan is used to just to speed up the process. So after enter and pass the heat exchanger in this coil, the refrigerant is still in high pressure. Its temperature is become medium because of heat loss, and it changed state from saturated liquid state because of the condensation. So basically, along this tube there is a liquid form, and this liquid will goes into the checking valve. So this checking valve only will flow the refrigerant in one direction only, so it will flow into a expansion valve. From the name of itself, this expansion valve will remove the pressure inside the fluid that goes here. So it will lower the pressure, lower the temperature, as well as change the phase of the liquid that goes into the expansion valve. And then this mixture vapor phase will goes up into another exchange coil, which is heat exchanger coil, will provide more heat from the surrounding, and then it will cause the provide heat from the surrounding, and this heat will be stuck on this mixture. So by mean this blue indicate the lower pressure, medium to low temperature, and it changed the phase also because of this heat exchanger and a fan. So it changed into a saturated vapor state, which will goes back into a reversing valve. So this flow will go back into reversing valve, and then this reversing valve will decided where is the refrigerant want to go. So it will go straight back to the compressor. So it will repeating the process or the cycle again and again. So this is how the heat pump works.
Okay, thank you Azlan. First, let me introduce myself. My name is Anel Kadao Anakupo and my matrix number is 208569. So, first, I would like to explain about the first law of thermodynamics that involved in the heat pump application. Since my group was choose the air source heat pump application, first thing first we need to know what's the component that involved in the system. As you guys can see at the picture, there are two sides, which is outdoor unit and indoor unit. For outdoor units, it represents the condenser, while the indoor unit is represent the evaporator. For the component that involved in the outdoor units, which are heat exchanger coil, expansion valve, check valve, reversing valve, fans, and compressor. While in the indoor units, the components involve heat exchanger coil, expansion valve, check valve, and fan. Without further ado, let's talk about the definition of the first law of thermodynamics. Generally, the first law of thermodynamics can be stated as a heat in the form of energy, and thermodynamics is a process where it's subjected to the principle of conservation energy. This means the heat energy cannot be created or destroyed. So in the case of the heat pump, the increasing in internal energy of the system is equal to the thermal energy added plus with work done by the system. So it can be formulated into formula which is QH equal to QC plus W. So for the QH is represent the thermal energy was transferred into the system, while QC is the thermal energy that taken from the outside of the system, and W is the work done by the system. So for the air source heat pump application, we can see that the first law of thermodynamics occurs where the temperature of the substance in the system is higher than the air temperature from the outside of the system. So this means this action will allow the heat exchange to occur in the system. Besides, when the temperature of the substance in the system is equal to the air temperature from the outside of the system, heat exchange does not occurring and the conditioning system does not work. So, as a conclusion, the heat will transfer to the surrounding. So I think that's all from me. I will pass to this presentation to the next presenter. Thank you.
Thank you, Anelka. Hello, everyone. My name is Viviana. I will present about the principle of second law of thermodynamics. So, as we know, thermodynamics started in many ways, but it's made difference. But this way are in phase. As we know, the familiar second law of thermodynamics is heat transfer from hot to cools. Okay, let's start with, we can see with heat pump process, where the heat pump process where the gas in the compressor, the compressor helped by electrics to increase the temperature and pressure of the gas, and after that it's pass the gas to the reversing valve, and through the reversing valve to the heat exchange coils. So at here the high temperature will condense to liquid. This is because the high temperature of the gas is more high than the temperature in the room, so it's condensed and become a liquid. So here we can see the second law of thermodynamic occur, which is from the different temperature. It is from the hot and always flow to the cools. So this is proof the presence of seconds of thermodynamics. Then the liquid will flow through the expansions valve and back to compressor as a gas. So as you know, cooling heat pump have two mode, which is cooling mode and heat mode. So other than that, this pump process have a reverse process. This means it involves Carnot circle principle, which is also the part of the second law of thermodynamics. Okay, that's all from me. Thank you.